October 11, 1942, Wright Field, Dayton, Ohio, 11:34 p.m. The Army Air Force's engineering officer stopped counting at Regulation Violation 17, overwhelmed by the sheer audacity of what civilian mechanics had done to a military aircraft without authorization. Major Thomas Hitchcock, Chief of Fighter Development and a man who had spent 3 years ensuring that every modification to AAF aircraft followed strict procurement protocols, stood on the tarmac watching a P-51 Mustang taxi in from a test flight that should never have happened. The aircraft's engine, a British Rolls-Royce Merlin that absolutely, explicitly, categorically was not approved for installation in American fighters, hummed with a power that made the original Allison-equipped Mustangs sound like agricultural machinery. What Hitchcock didn't know was that he was witnessing the culmination of a 6-month rogue engineering project that had violated multiple military regulations, ignored direct orders from procurement offices, and accidentally created the fighter that would win air superiority over Europe. The P-51 Mustang with the illegal engine, a fighter that military procurement officers had called adequate until a civilian mechanic named Ronald Harker ignored regulations and installed a power plant that transformed it into the deadliest fighter of World War II. But in October 1942, as America mobilized for global war against enemies who already possessed air superiority, the aircraft flying overhead represented either the solution to an impossible problem or the largest unauthorized modification in Army Air Force's history. The story begins not with the Mustang, but with a British Purchasing Commission's desperate gamble that accidentally created an airframe nobody knew what to do with. April 1940, North American Aviation, Inglewood, California. The British Purchasing Commission, scrambling to acquire fighters as the Luftwaffe prepared to attack Britain, approached North American Aviation with an unusual request. Could the company manufacture Curtiss P-40 fighters under license to supplement RAF fighter strength? North American, primarily a trainer manufacturer with minimal fighter experience, responded with a counterproposal that bordered on arrogance. Rather than building someone else's mediocre fighter, they would design a superior aircraft from scratch and deliver the prototype in 120 days. The British, skeptical but desperate, agreed. North America's chief designer, Edgar Schmude, assembled a team and began work on what would become the NA-73, later designated P-51 Mustang by the U.S. Air Force. Schmude's design philosophy prioritized speed and range over maneuverability, laminar flow wings minimizing drag, streamlined fuselage reducing frontal area, and internal fuel capacity exceeding any contemporary fighter. The result was an aircraft optimized for the escort role Britain desperately needed, fighters that could accompany bombers deep into German territory. But the prototype that rolled out in October 1940 had a critical limitation: the Allison V-1710 engine. The Allison was a capable power plant at low and medium altitudes, producing 1,150 horsepower and enabling the Mustang to reach 390 miles per hour below 15,000 feet. But the engine's single-stage supercharger meant performance degraded dramatically at high altitude. Above 20,000 feet, where RAF and Luftwaffe fighters routinely operated, the P-51's speed dropped below 340 miles per hour, and its rate of climb became inadequate for intercepting German bombers or engaging enemy fighters effectively. The RAF began receiving Mustangs in late 1941 and quickly recognized both the aircraft's potential and its fundamental flaw. At low altitude, the Mustang was the fastest fighter in RAF service, perfect for ground attack and tactical reconnaissance. But for high-altitude bomber escort or intercepting Luftwaffe raids, the aircraft was useless. The superlative airframe was shackled to an engine that couldn't exploit its capabilities. which is where Ronald Harker enters the story, a British Rolls-Royce test pilot who wasn't supposed to be thinking about American fighters. Harker, flying evaluations of RAF aircraft at the company's Hucknall facility in early 1942, requested an opportunity to fly the Mustang after hearing pilots praise its low-altitude performance while complaining about high-altitude limitations. On April 30, 1942, Harker flew a Mustang 1 belonging to 26th Squadron. His assessment was immediate and enthusiastic. The Mustang possessed the finest aerodynamic design he'd encountered, exceptional handling characteristics, and performance that would be transformative if coupled with an engine maintaining power at altitude. Harker understood exactly which engine, the Rolls-Royce Merlin 61, equipped with a two-stage, two-speed supercharger that maintained power output to 30,000 feet. The Merlin 61 was powering the Spitfire 9, giving the RAF its first fighter capable of matching the latest German Focke-Wulf FW-190. Harker's insight was recognizing the Mustang's superior aerodynamics combined with the Merlin's high-altitude performance would create a fighter exceeding both the Spitfire and FW-190. But Harker was a test pilot, not an aircraft designer or procurement officer. His job was evaluating production aircraft, not proposing radical modifications to foreign fighters. Rolls-Royce had no contract with North American Aviation, no authorization to modify American aircraft, and no business suggesting that British engines should replace American power plants in U.S. military fighters. The appropriate procedure was writing a report recommending further study, submitting it through official channels, and waiting for procurement offices to evaluate feasibility. Harker did something different. He walked into Rolls-Royce's Hucknall engineering office and asked Chief Engineer Jim Eller a simple question. Would the Merlin physically fit in the Mustang's engine bay? The answer was yes, barely. The Merlin was larger than the Allison, but the Mustang's engine bay had been designed with generous clearances. Eller's preliminary measurements suggested that a Merlin could be installed with modified engine mounts, relocated accessories, and a new radiator arrangement to handle the Merlin's different cooling requirements. The modification was feasible, though it would require extensive engineering to achieve proper weight distribution, maintain the center of gravity within acceptable limits, and ensure structural integrity. But feasibility didn't mean authorization. Rolls-Royce had no permission to modify American military aircraft. North American Aviation hadn't been consulted. The U.S. Army Air Forces, which had just begun receiving Mustangs and remained skeptical about the aircraft's value given its high-altitude limitations, hadn't approved any engine change. And British procurement authorities, dealing with desperate fighter shortages, had neither time nor resources for experimental modifications. Harker and Eller proceeded anyway. In June 1942, they secured an airframe, a Mustang that had suffered landing gear damage and been withdrawn from squadron service, and a Merlin 65 engine from a damaged Spitfire. The work was conducted quietly, without fanfare or official sanction, in a corner of the Hucknall facility where Rolls-Royce conducted experimental projects. The modification was treated as internal research, avoiding questions about authorization or regulatory compliance. The installation required 3 months. Engine mounts had to be fabricated from scratch, designed to handle the Merlin's different mounting points and vibration characteristics. The Merlin's propeller reduction gearbox sat lower than the Allison's, requiring a different firewall arrangement. The Merlin's cooling system generated more heat than the Allison's, necessitating a larger radiator positioned differently in the airframe. Most critically, Merlin's two-stage supercharger and intercooler added weight and complexity, requiring engineers to relocate batteries, radios, and other equipment to maintain an acceptable center of gravity. The aircraft that emerged in October 1942 was designated Mustang X, a one-off experiment that violated multiple regulations. No formal approval had been obtained from the U.S. Army Air Forces. North American Aviation had been informed only after work began, receiving vague assurances that Rolls-Royce was conducting evaluation studies. British procurement authorities, dealing with desperate fighter shortages, had neither time nor resources for experimental modifications. The entire project existed in a regulatory gray area, technically illegal but tolerated because nobody with sufficient authority had explicitly forbidden it. Test flights began on October 13, 1942. Harker, as the pilot who had conceived the modification, conducted initial flights. The results exceeded expectations. The Mustang X achieved 433 miles per hour at 22,000 feet, 43 miles per hour faster than the Allison-powered Mustang at that altitude. Rate of climb increased from 2,600 feet per minute to 3,800 feet per minute. Service ceiling rose from 30,000 feet to 41,000 feet. Every performance metric improved dramatically, transforming an aircraft that was useless at high altitude into one that dominated. Rolls-Royce engineers documented the results and submitted reports through official channels, suddenly discovering bureaucratic enthusiasm for a project that had been conducted without authorization. The Air Ministry, recognizing the strategic implications, approved the immediate conversion of 5 additional Mustangs using Merlin 1650 engines. North American Aviation, informed that their aircraft's performance could be dramatically improved through a simple engine change, expressed interest in manufacturing Merlin-powered Mustangs under license. But American military procurement officers remained skeptical. The P-51 Mustang wasn't a priority aircraft for the U.S. Army Air Forces. American fighter doctrine emphasized high-altitude interceptors like the P-38 Lightning and P-47 Thunderbolt. The Mustang, originally designed for British requirements, had been ordered in limited numbers primarily for ground attack roles. Converting existing Mustangs to Merlin engines would disrupt production, require expensive retooling, and divert resources from aircraft already established in AAF service. Then, combat results from Europe forced a re-evaluation. U.S. 8th Air Force, conducting daylight bombing raids over Germany from bases in England, suffered catastrophic losses during 1943. German fighters exploited the fundamental limitation of American escort fighters: inadequate range. The P-47 Thunderbolt, heavily armed and capable at high altitude, could escort bombers only to the German border before fuel limitations forced them to turn back. Unescorted bombers penetrating deep into Germany faced annihilation. Loss rates approached 20% on some missions, absolutely unsustainable for continued operations. The Army Air Forces desperately needed long-range escorts. Every available fighter was evaluated for range extension: drop tanks, reduced armament to save weight, and modified engines for fuel efficiency. But no existing fighter could escort bombers to Berlin and back, a round trip exceeding 1,000 miles, requiring approximately 6 hours of flight time. The strategic bombing campaign, central to American strategy, was failing because escorts couldn't protect the bombers where protection was needed most. Major Thomas Hitchcock, assigned to fighter development and previously skeptical about the Mustang, reconsidered the Merlin conversion after reviewing British test data. The Mustang X possessed the range American doctrine required: internal fuel capacity of 269 gallons, plus provisions for drop tanks could enable missions exceeding 1,500 miles. Combined with Merlin performance, the aircraft could escort bombers to any target in Germany, while maintaining combat effectiveness against Luftwaffe interceptors. Hitchcock advocated for immediate Mustang production conversion to Merlin engines, but American military procurement faced a problem. Rolls-Royce couldn't manufacture enough Merlin engines for British Spitfires and Lancasters, much less additional American fighters.
The solution was Packard Motor Company, which had been manufacturing Merlins under license for British aircraft since 1941. Packard Merlins, designated V1650, were mechanically identical to British engines, but manufactured using American production techniques and materials. In July 1943, the Army Air Forces authorized North American Aviation to redesign the P-51 for the Packard Merlin. The resulting aircraft, designated P-51B, entered production in August 1943. The first operational Mustangs with Merlin engines reached Europe in November 1943.
The impact on the air war was immediate and decisive. P-51 Mustangs began escorting 8th Air Force bombers to targets throughout Germany, remaining with bomber formations through the entire mission profile. German fighters, accustomed to attacking unescorted bombers with minimal opposition, suddenly faced American fighters possessing equal or superior performance at all altitudes. Luftwaffe loss rates increased dramatically. German fighter pilot attrition reached unsustainable levels as experienced pilots were killed faster than replacements could be trained. The statistics were stark. During the first quarter of 1944, before P-51s achieved widespread deployment, 8th Air Force bomber loss rates averaged 5.1% per mission. By the second quarter, with P-51s providing deep penetration escort, loss rates dropped to 3.6%. By the third quarter, as P-51 production increased and tactics refined, bomber losses declined to 2.8%. Sustainable rates that enabled the strategic bombing campaign to achieve operational objectives. But the Mustang's significance extended beyond escort duties. The aircraft's range enabled offensive fighter operations deep over German territory, attacking airfields, strafing transport, and destroying Luftwaffe aircraft on the ground. German fighters, forced to engage escorting Mustangs or face attacks while landing and refueling, suffered losses in the air and on the ground. By early 1944, the Luftwaffe had effectively lost air superiority over Germany. American fighters operated with impunity, while German fighters couldn't effectively defend against daylight bombing. German pilots developed profound respect and fear of the Mustang. Luftwaffe tactical reports from 1944 consistently noted the P-51's superior speed, climb rate, and maneuverability. German pilots discovered they couldn't dive away from Mustangs as they had from P-47s. The Mustang matched or exceeded German fighters in every performance category. The psychological impact was significant. German fighter pilots, who had dominated European skies for 4 years, suddenly faced American opponents possessing technical superiority. Production numbers reflected the Mustang's strategic importance. North American Aviation manufactured 15,586 P-51s between 1942 and 1945. More than any other American fighter except the P-47 Thunderbolt. Peak production reached over 500 aircraft monthly by mid-1944. The Mustang equipped 26 fighter groups in the European theater and multiple groups in the Pacific, becoming the primary American fighter for the final year of the war. But the aircraft's success masked the irregular origins of the Merlin conversion. Official histories credit engineering evaluation and systematic testing for identifying the benefits of combining the Mustang airframe with the Merlin engine. The reality was that a single test pilot, acting without authorization and violating multiple regulations, had installed a British engine in an American fighter because he thought it might work. The modification succeeded not through systematic analysis, but through empirical testing conducted before anyone with sufficient authority could forbid it. Ronald Harker received no public recognition for conceiving the Merlin Mustang conversion.
His contribution was documented in Rolls-Royce internal reports and acknowledged by engineers who understood the project's history, but official accounts attributed the conversion to institutional processes rather than individual initiative. Harker continued as a Rolls-Royce test pilot through the war, evaluating aircraft and engines, but never received the acclaim his insight deserved. The irony was absolute. The modification that military procurement officers would have rejected as impractical, installing a British engine in an American fighter, requiring extensive redesign and disrupting established production, became the single most important fighter development of the year. Production numbers reflected the Mustang's strategic importance. North American Aviation manufactured 15,586 P-51s between 1942 and 1945, more than any other American fighter except the P-47 Thunderbolt. Peak production reached over 500 aircraft monthly by mid-1944. The Mustang equipped 26 fighter groups in the European theater and multiple groups in the Pacific, becoming the primary American fighter for the final year of the war. But the aircraft's success masked the irregular origins of the Merlin conversion. Official histories credit engineering evaluation and systematic testing for identifying the benefits of combining the Mustang airframe with the Merlin engine. The reality was that a single test pilot, acting without authorization and violating multiple regulations, had installed a British engine in an American fighter because he thought it might work. The modification succeeded not through systematic analysis, but through empirical testing conducted before anyone with sufficient authority could forbid it. Ronald Harker received no public recognition for conceiving the Merlin Mustang conversion. His contribution was documented in Rolls-Royce internal reports and acknowledged by engineers who understood the project's history, but official accounts attributed the conversion to institutional processes rather than individual initiative. Harker continued as a Rolls-Royce test pilot through the war, evaluating aircraft and engines, but never received the acclaim his insight deserved. The irony was absolute. The modification that military procurement officers would have rejected as impractical, installing a British engine in an American fighter, requiring extensive redesign and disrupting established production, became the single most important fighter development of the European Air War. The illegal conversion that violated regulations and ignored proper authorization procedures created the weapon that won air superiority over Germany. The P-51's technical influence extended far beyond World War II. Post-war fighter design incorporated lessons from the Mustang's success. Range mattered as much as performance. Aerodynamic refinement enabled higher speeds than brute engine power, and careful integration of power plant with airframe produced capabilities exceeding what either could achieve independently. The laminar flow wing technology pioneered on the Mustang influenced every American fighter developed through the 1950s. The emphasis on range and endurance shaped tactical doctrine for decades. But the P-51's greatest legacy was demonstrating that transformative innovations often emerge from unconventional sources. Military procurement systems, optimized for reliability and risk management, inherently resist radical changes. Revolutionary improvements typically require someone willing to circumvent established procedures, test unconventional solutions, and demonstrate results before seeking approval. Harker's modification succeeded precisely because he didn't follow proper channels. Official evaluation would have identified numerous reasons to reject the conversion before testing proved it worked. The mechanic's illegal idea, except Harker was a pilot, not a mechanic, created America's deadliest fighter not through brilliant analysis, but through willingness to try something that regulations forbade. The Merlin Mustang conversion seemed obvious in retrospect. superior airframe plus superior engine equals superior fighter. But obvious solutions aren't implemented when institutional processes prioritize risk avoidance over innovation. Someone had to ignore the rules, conduct the modification without authorization, and present results that couldn't be dismissed. Harker did that, and in doing so, accidentally solved the Army Air Force's most critical tactical problem. The officers who had dismissed the Mustang as adequate for ground attack spent 1944 and 1945 desperately requesting more P-51s for every fighter group. The procurement officials who had deprioritized Mustang production scrambled to increase output and convert existing aircraft to Merlin engines. The military establishment that valued proper authorization above empirical results discovered that the unauthorized modification they should have prevented had won the air war.
In aviation museums today, P-51 Mustangs sit on display, their Merlin engines and distinctive profiles instantly recognizable. Museum placards describe the aircraft's technical specifications, combat record, and strategic significance. No mention that the fighter's defining characteristic, the Merlin engine that made everything else possible, was installed initially without authorization, in violation of regulations, by people who had no business modifying American military aircraft. What the placards don't explain is that military effectiveness sometimes requires ignoring military regulations. The P-51 Mustang was transformed from an adequate low-altitude fighter into the war-winning escort that defeated the Luftwaffe because one test pilot didn't ask permission before testing an idea that procurement officers would have rejected. The illegal modification that should never have happened created the weapon that won air superiority over Europe. Ronald Harker flew a Mustang on April 30, 1942, recognized that the airframe needed a better engine, and installed one without waiting for authorization. 5 months later, the Mustang X demonstrated performance that changed American fighter doctrine. 18 months later, P-51Bs were escorting bombers to Berlin. 30 months later, Germany had lost the air war, partially because American fighters dominated the skies that the Luftwaffe had controlled for 4 years. The mechanic's illegal idea, technically a test pilot's unauthorized modification, became the fighter that made strategic bombing possible, that won air superiority over Europe, and that enabled Allied victory through a campaign that couldn't have succeeded without long-range escorts. The modification that violated regulations proved correct, while the regulations that forbade it proved counterproductive. The lasting lesson extends beyond the P-51 specifically. Military innovation faces inherent tension between institutional stability and tactical necessity. Regulations exist for valid reasons, ensuring safety, maintaining quality control, and preventing unauthorized modifications that could cause catastrophic failures. But regulations also prevent experimentation, discourage unconventional solutions, and delay adoption of technologies that challenge established systems. The optimal approach, balancing innovation with stability, requires tolerance for controlled rule-breaking. Harker's conversion succeeded because Rolls-Royce permitted experimental projects. After all, British procurement authorities didn't actively forbid the modification, and American observers recognized valuable results despite questionable origins. Organizations that punish all unauthorized innovation eliminate breakthrough solutions along with dangerous failures. 79 years after Harker's test flight, the P-51 Mustang remains the definitive American fighter of World War II. Not the most numerous, the P-47 exceeded it. Not the most powerful, the P-38 mounted heavier armament, but the most significant because it solved the unsolvable problem: how to escort bombers to any target in Germany and fight effectively when they got there.
The Mustang did what no other fighter could, enabling the strategic bombing campaign that destroyed German industrial capacity and forced Germany to divert resources from other fronts to air defense. The fighter that won the air war existed because one person ignored regulations prohibiting what needed to be done. The illegal idea became the essential weapon, and the mechanic, actually a test pilot, who conceived the modification that transformed American air doctrine, received none of the recognition his contribution deserved. Sometimes the heroes are forgotten while their accomplishments persist. Sometimes the illegal solution saves the war. And sometimes the greatest innovation comes from someone willing to try what everyone else knows is forbidden. The Merlin Mustang conversion was unauthorized, improper, and contrary to established procurement procedures. It was also correct, necessary, and ultimately decisive. The aircraft that shouldn't have been modified became the fighter that couldn't be matched. Sometimes breaking the rules creates the weapon that wins the war.